Okay, and now we're going to solve the system by graphing. So this should say by graphing, because that's what we're focusing on today. And we're going to recall how to graph our lines. So this one, I'm going to put the axis in the middle, approximately. Y, X. Okay, so I'm going to do this guy in red, this guy in a different purple. And so when we are graphing, we always start with the y-intercept first. So I'm just going to make a note. So 1, plot y-intercept. That's your first step. And 2, use your slope, m, which is your slope, to plot the next points. So what I mean by that is if we look at the y-intercept, which is 3, positive 3, and we start here, and then I look at the slope, which is 2, the slope is m, right? So y-intercept is b, and the slope is m, which is a number in front of x, so it's going to go up 2 over 1, up 2 over 1, and I can even go backwards in my pattern, and then with a ruler, which I don't have, I'm going to graph it. And because we're going to plot more than one equation on the same graph, we definitely have to label this one. There we go. I'm going to do the same thing, but the other one. So my y-intercept, step 1, plot the y-intercept, which is negative 5. 1, 2, 5, which is down here. Ooh, I didn't draw this right, but that's okay. And the slope is down 2 over 1. So it would be there, but let's go backwards. And I'm going to, with a ruler, that was what I wanted. With a ruler, best we can. Oh, also not the right color. There we go. That one's a little bit wobbly, but I'm going to label it. And so our point of intersection is that point right there, which we know is -2, -1. So now we're going to verify or check our solutions. So I know that the first equation, the left side is y, which is -1. The right side is 2 times -2 plus 3, which is -4 plus 3, which is -1. Awesome. And we do the same thing to the other side. So the left side is y, which is -1. The right side is -2x, which is -2, minus 5, which is 4 minus 5, which is -1. Amazing. So we've checked our solutions, both sides, and we're good to go. And then we want to do the other one, but we have a problem. So this equation, the second one here, is not in y equals mx plus b form, and we need to make it that way. So we are going to do that first by isolating y, so getting y by itself. So I'm going to keep the 2y on this side, and I'm going to move the x to the other side. And I'm going to, actually, yeah, I'm going to do the 14 at the same time. Oops, I wrote 15. plus 14. So then 2y equals negative x plus 14. Divide everything by 2. Y equals negative x over 2. We just keep that as a fraction, plus 7. Here we go. We're going to draw our axes. So that's y, and then our x. Here we go. Again, I'm going to use red as this one, and so our slope, there's no number in front of x, but there's an invisible 1, so don't forget that, and that means that when we start our graph, we are going to plot our y-intercept. That's step 1, which is b, which is positive 1, and then our slope is 1, so it's going to go up 1 over 1, up 1 over 1, and it's going to look like this all the way across, and we can trace it back, and then with a ruler, and then we label. Don't forget to label. Make a note for yourself right now. Put label lines. Note to self. Okay, and then we're going to graph the second one, which I'm going to use this equation for, our graphing format, our y-intercept format, and I'm going to start with our y-intercept of positive 7. 1, 2, 3, 4, 5, 6, 7. Ooh, did the same thing on the other graph. Nice. Okay, and then it's going to go down 1. Remember that there is a 1 here. Down 1 over 2. So down 1 over 2, down 1 over 2, down 1 over 2, and there is our other line. So that is, you can write it this way, but we did all that work to make it into the nice y-intercept form, so we might as well label it that way. Y equals, y equals negative x over 2 plus 7. And so our point of intersection, this guy right here, and therefore our point of intersection is 4 and 5. 4, 5. That's the coordinates of that highlighted point. And I'm just going to change my formatting over here. Point of intersection is that. And then we have to check, verify. Don't forget to verify. So the left side is y, which is 5. And the right side of the right equation is x, which is 4, plus 1, which is 5. Nice. And then we do the same thing to the other one. I'm actually going to use the original equation to check, just to show that, it doesn't matter which one you use. If you can use the other one, you should get the same on each side. So the left side is x, which is 4, plus 2y, which is 5, minus 14. And my right side should give me 0. So that is 4 plus 10 minus 14, which is in fact 0. So we have found the point of intersection of both lines, and we double checked and showed that we can check using algebra that those are in fact the solutions to our system of equations.